Welcome to Curiosity, the podcast where science meets wonder. Join us as we explore the fascinating, the innovative, and the unexpected, from the secrets of the cosmos to the marvels of everyday life. Each episode takes you on a journey to uncover the knowledge and stories that fuel our endless quest for understanding. Let your curiosity guide you.
Okay, let's unpack this. What's the most profound, maybe the most personal mystery you carry around with you every single day? It's right there, isn't it? Behind your eyes, kind of creating your entire world. It's the reason you can hear my voice right now, process these words, even, think about what they mean.
Yeah, absolutely. We're talking about consciousness.
Exactly. Consciousness, that utterly subjective, undeniable experience of just being you. Today, our deep dive takes us right into the enigma of awareness, unraveling consciousness, and we're going to explore some of the, frankly, most fascinating and challenging questions out there right at the edge of science and philosophy.
The big one.
It really is. The stack of sources we've got here, they really delve into this incredibly intricate world inside your skull, billions of neurons firing away.
Electrical signals, chemical signals, cascades of activity.
Cascading, exactly. And the huge question is how, from all this, purely biological activity, your unique experience reading this, understanding it, reflecting on it, how does that emerge?
That leap is the mystery.
Right. So our mission today is to try and cut through some of that immense complexity, pull out the most important insights into why consciousness is still seen by so many as, well, the last great mystery.
It's often called that, yeah.
We'll journey through the philosophical foundations, look at the latest neuroscience, and importantly, what all of this means for our future, for things like AI, and even just for understanding ourselves better.
And what truly sets this puzzle apart, I think, is its fundamental nature. It's almost elusive.
Yeah.
For centuries, philosophers have been grappling with this mind-body problem, and even now, with all our incredibly advanced neuroscientific tools, fMRI, EEG, the works.
They can see so much activity.
We can see a lot.
Yeah.
But the actual how consciousness emerges from that neural activity, it's still stubbornly elusive.
Still slippery.
Very. And this isn't just some, niche academic problem tucked away in a university department.
No, it feels much bigger.
It absolutely is. It sits right at the intersection of neuroscience, philosophy, physics, even artificial intelligence. It fundamentally challenges our core assumptions about reality itself and ultimately what it even means to be human.
That's heavy stuff.
It is. So we'll journey through this whole intellectual landscape, starting with some basic definitions or the problems with defining it, all the way to these really revolutionary, sometimes quite controversial theories.
The goal being to help you, our listener, really understand the core arguments.
Exactly. And the huge implications of solving this puzzle. Or perhaps the implications of not solving it. It's the ultimate puzzle of existence in many ways.
Okay, so before we even try to solve it, we probably need to grapple with that more basic question you alluded to. What is consciousness?
Right. Where do you even start?
It feels so immediate, doesn't it? So undeniably real and personal for each of us. But then you try to pin down a precise definition.
And it just melts away. It gets really slippery.
Yeah. Why is it so hard to define? Is it just because it's internal?
Well, that's a huge part of it. It's inherently subjective and private. Your inner experience is yours alone.
Right. I can't climb inside your head and see your red.
Exactly. You can't observe it directly from the outside. That's the fundamental challenge for a scientific approach.
Philosophers have a term for this, right? This subjective quality.
They do. They often call it qualia. It refers to the what it's like aspect of experience, the qualitative feel.
Okay. Give us some examples, like the redness of red.
Perfect example. The redness of a red rose. It's not just the light waves hitting your retina, which we can measure. It's that indescribable, vivid, subjective quality of the color itself. That particular feeling of red that only you experience from the inside.
Or, okay, like the pain of a pinprick.
Yes. Yeah. Or accidentally biting your tongue, that sharp, sudden pain. It isn't just the neural signals firing off a warning.
No, it's the actual ouch.
It's the ouch. That distinct, undeniable sensation that hits you, sometimes makes you see stars, That's qualia.
Okay, what about taste? Like chocolate?
The taste of chocolate, absolutely. It's more than just the chemical interactions on your taste buds. It's that unique, complex, maybe delightful flavor profile. It might even bring back memories, that whole rich experience.
And emotions, too, like feeling sad.
The feeling of melancholy or joy or fear. These complex emotional states, they can't just be reduced to a specific brain region firing, even if we know which regions are involved. It's the subjective texture of the feeling itself.
So all these examples, redness, pain, taste, feelings, they're all qualia.
Exactly. And this subjective qualitative property is precisely what makes consciousness so profoundly puzzling. It pushes us way beyond just thinking about the brain as an information processor.
It's not just data crunching.
No, it's not just data, it's experience.
Yeah.
And that inherent difficulty in defining it, in capturing qualia. Actually, that's exactly where Chalmers' famous hard problem really starts to bite. We'll definitely get into that.
Okay.
Because, you see, we can map the neural circuits processing, say, light waves of 700 nanometers. We can track the activation patterns all the way through the visual cortex.
We've gotten really good at that part.
Incredibly good. But that leap from describing the physical mechanisms to explaining the experience of seeing red, that specific quale, that's where science often feels like it hits a wall.
The explanatory gap.
Precisely. We understand the physical nuts and bolts, but not why they generate this subjective inner life. And, to add another layer of complexity here, consciousness isn't just a simple on-off switch.
Right, it's not like a light bulb.
No, it seems to exist along multiple dimensions. Understanding these different layers helps us grasp the full scope of the mystery we're dealing with.
Okay, so what are some of these dimensions?
Well, for instance, we really need to clarify the difference between wakefulness and awareness. They sound similar, but they're not the same thing.
How so?
You can be awake, your eyes are open, your body might be moving but not fully aware. Think about sleepwalking.
Okay. The body's active, but the mind isn't really home.
Exactly. Your conscious mind isn't fully engaged with the surroundings. Conversely, you can be aware, perhaps intensely aware, but not fully awake. Think about vivid dream states.
Right, you're experiencing a whole rich inner world, even though your body's totally at rest.
Precisely. So wakefulness is more about the physiological state, while awareness is about the content, the experience itself.
That's a useful distinction. What else?
Then there's selective attention. Our consciousness seems to act like a spotlight, right? It highlights certain aspects of our experience while leaving others in the shadows in the background.
Like right now, I'm focused on our conversation.
Exactly. You're consciously aware of these words of my voice, but perhaps only now, because I mention it, are you becoming conscious of, say, the feeling of your clothes against your skin.
Yes, now I am. Okay.
Or the ambient sounds in the room that you were filtering out.
Yeah.
That's your attention shifting, focusing the beam of your awareness. We select what enters the main stage of consciousness.
And we do that constantly without even thinking about it.
Constantly. And building on that, there's a particularly sophisticated form, especially prominent in humans, self-awareness.
Being aware that you are aware.
Exactly. The capacity for being aware of being aware. The ability to reflect on our own mental states, to know that I am the one having these thoughts and feelings, to recognize ourselves as the subject, the experiencer of these experiences.
Like looking in a mirror and knowing it's you.
That's a classic test, yes.
Yeah.
But it goes deeper into introspection, understanding our own minds.
Okay. Wakefulness versus awareness, selective attention, self-awareness, anything else.
One more crucial aspect is the remarkable unity of consciousness. Think about this.
Yeah.
Your brain processes information in a highly distributed way.
Right. Different areas handle vision, sound, touch.
Exactly. Color might be processed over here, motion over there, faces somewhere else entirely. But your subjective experience isn't fragmented like that, is it?
No, it feels completely seamless, like one continuous movie.
Precisely. You don't experience separate visual, auditory, and tactile streams of consciousness that you then have to stitch together. Instead, all these sensory inputs are seamlessly bound into one unified, coherent experience of the world around you, moment by moment.
That's actually amazing when you stop to think about it. How does that happen?
Well, that phenomenon, where all these disparate pieces come together so smoothly, leads directly to what neuroscientists call the binding problem.
The binding problem. Okay.
How does the brain combine all these separate sensory inputs processed in different specialized regions into one fluid, unified, conscious experience? How do the features of an object, its color, shape, motion, sound, get integrated into a single, cohesive, conscious percept?
Like seeing and hearing a bouncing ball as one single event, not separate sensations.
Exactly like that. It's a central, ongoing puzzle. It really highlights the incredible complexity underlying what we just take for granted every single waking moment. How does the brain bind it all together?
Okay, so we've talked about how tricky defining consciousness is, these layers like attention and self-awareness. and now this binding problem. But it feels like we're still circling this core mystery. Why do we have these experiences at all? You mentioned a framework that tried to get at this.
Yes, that's where the philosopher David Chalmers comes in. His work in, I believe it was in 1995, really reshaped the whole conversation.
How so?
He provided this crucial framework by separating what he called the easy problems of consciousness from the hard problem. And that distinction has really stuck.
Why? Because it helps clarify things.
It helps us understand why we've made so much progress in some areas of studying the brain and behavior, but are still, frankly, utterly baffled by the core phenomenon itself. You mentioned the why, question why experience, and that's exactly what Chalmers zeroed in on with the hard problem.
Okay, so let's tackle the easy ones first then. But just to be clear, when we say easy, we don't mean simple, right?
Oh, absolutely not. These are monumental scientific challenges in their own right. They involve understanding incredibly complex brain functions.
But they're considered more tractable, more approachable for science.
Exactly. More tractable compared to what Chalmers dubbed the hard problem. So the easy problems involve explaining the functions associated with consciousness, the cognitive abilities and behaviors.
Like what, specifically?
Well, for example, how the brain integrates information from different senses, like we just talked about with the binding problem, how seeing a car, hearing its engine, and maybe feeling the vibration all merge into one coherent perception. That's an easy problem, functionally speaking.
Okay, figuring out the mechanism of integration.
Right. Or how the brain manages to focus attention, like you focusing on this conversation while filtering out background noise. Understanding the mechanisms of selective attention is another easy problem.
And how information becomes available.
Yes, how information becomes globally available for reasoning and reporting. How does a thought or a perception get broadcast across different brain systems so you can consciously reflect on it, talk about it, or use it to guide your actions? That's another one.
Makes sense. What else falls under easy?
The mechanisms of sleep and waking cycles. How the brain transitions between these different states of consciousness, deep sleep, dreaming, drowsiness, full alertness, and how it regulates those cycles. That's functionally definable.
And monitoring internal states, like feeling hungry.
Exactly. How the brain monitors its own internal states, things like hunger, thirst, body temperature, even recognizing your own emotions to some extent. These allow for self-regulation.
So why are these considered easy, relatively speaking?
Because we have clearer paths forward for investigating them. We can design experiments, use brain imaging like fMRI or EEG to measure neural activity related to these functions, track information flow, build computational models, and gradually develop theories that explain how these functions are performed by the brain.
We have the tools and the conceptual framework to study brain function.
Precisely. And neuroscience has made enormous progress here, mapping out many of these processes in incredible detail. We know a lot about how the brain does these things.
Okay, so the easy problems are about how the brain works and what it does functionally. But you mentioned a hard problem. What makes that so uniquely stubborn?
Right. The hard problem, as Chalmers defined it, isn't about explaining the functions. It's not about how the brain processes information or controls behavior. It's about why. Why is all that processing accompanied by subjective experience?
Why does it feel like something from the inside?
Exactly. Why does it feel like anything at all to be a brain doing all that complex work? Why aren't we just incredibly sophisticated biological machines, wetware, computers, processing data, reacting to stimuli, making decisions, but with absolutely no inner light on, no sense of being?
Just darkness inside, functionally perfect, but subjectively void.
Precisely. We can imagine, at least conceptually, a machine that performs all the functions covered by the easy problems. It integrates information, focuses attention, learns, adapts, maybe even says ouch when damaged, but lacks any genuine inner subjective experience.
And that's where the zombies come in.
That's where Chalmers' famous thought experiment of philosophical zombies comes in, yes. It's a tool to isolate the hard problem. Imagine, he says, a perfect physical duplicate of yourself.
Looks like me, talks like me.
Acts exactly like you. Laughs at the same jokes, maybe claims to feel the same emotions, exhibits the same neural activity if you scanned its brain. It's behaviorally and functionally identical to a conscious human. But inside, there's nothing. No conscious experience, no qualia, no subjective feeling of a laughter, no inner awareness. Just pure, complex, unconscious information processing driving the behavior. That's a philosophical zombie.
It acts completely conscious but isn't.
Right. And Chalmers used this not to say zombies exist, but to highlight that the hard problem isn't about explaining the behavior or the function, which the zombie has, but explaining why we, presumably not zombies, have the accompanying subjective experience, that leap.
Neural activity to subjective feeling.
That's what remains profoundly mysterious. It feels like it requires a fundamentally different kind of explanation than the functional explanations we use for the easy problems.
Wow. Okay, that really crystallizes the challenge. But even if the hard problem feels, well, intractable sometimes, neuroscientists haven't just thrown up their hands, right?
Oh, absolutely not.
They're making remarkable progress, aren't they, in identifying the neural correlates of consciousness, NCCs, trying to find the brain activity that lines up with conscious moments.
Exactly. The NCC approach is all about finding the minimal neural mechanisms that are sufficient for a specific conscious experience. It's about looking at the brain in action, mapping the territory, even if we don't fully understand why that territory generates the map of experience.
So if you had to pick one core insight from all this NCC research, what's the most maybe surprising or significant thing it tells us about where consciousness actually happens in the brain or how it operates?
That's a great question. I think what's truly compelling is the growing consensus that consciousness isn't located in a single magical consciousness spot in the brain.
No little homunculus theater?
Exactly. No Cartesian theater. Instead, it seems to emerge from the dynamic interplay of specific, widespread brain networks. It's about integration, communication, and making information globally available.
So it's more about the network traffic than a single location.
Very much so. Let's explore some of the key networks implicated. A really crucial one is the thalamocortical system.
The thalamus and the cortex working together.
Precisely. The thalamus, this structure deep in the brain, acts like a central relay station, or maybe a gatekeeper. Almost all sensory information except smell goes through the thalamus on its way to the cortex.
So is it directing traffic?
In a sense, yes. And importantly, damage to certain parts of the thalamus can lead to a profound loss of consciousness, like coma. This highlights its crucial role in enabling conscious awareness. The cortex, the brain's outer layer, then provides the rich content of our conscious experience, our detailed perceptions, complex thoughts, memories.
So the thalamus opens the gate and the cortex provides the show.
That's a decent analogy. It's this dynamic loop, this constant back and forth communication between the thalamus and cortex that seems absolutely fundamental for maintaining a conscious state.
Okay, what other networks are key players?
Another fascinating one is the default mode network, DMN. What's interesting about the DMN is that it's most active not when you're focused on an external task, but when your mind is at rest.
Like when you're daydreaming.
Exactly. During introspection, mind wandering, thinking about yourself, remembering the past, planning the future, considering others' perspectives.
So the brain's idle state isn't really idle?
Not at all. It's busy constructing our sense of self, our internal narrative. Some researchers believe the DMN is potentially crucial for our ongoing sense of self-awareness, that feeling of being a continuous person through time. It's the network that hums along when you're just being you.
That's really interesting, sort of the brain's background operating system for our personal story. And then there's this idea of a global workspace. How does that fit?
Yeah, the global workspace theory, GWT, built on this idea of information sharing. It suggests that consciousness emerges when information processed by specialized, unconscious brain modules gets broadcast into a kind of central global workspace.
Like a central stage.
Exactly like a central stage, or maybe a shared bulletin board. Once information hits this workspace, it becomes widely available to many other brain systems simultaneously. For reporting, I see a red car. For reasoning, that car is going fast, I should wait. For memory encoding, and for guiding voluntary actions.
So consciousness is about information going wide, becoming globally accessible.
That's the core idea. Many things are processed unconsciously, backstage. Consciousness is what happens when something makes it onto the main stage, under the spotlight, accessible to the whole brain audience.
And do we know where this workspace might be located?
It's proposed as a network involving specific brain regions known for integration and high-level control, like parts of the prefrontal cortex, the parietal cortex, and the anterior cingulate cortex. These areas have extensive long-range connections, perfect for broadcasting information widely.
Okay, so networks seem key, but what about specific patterns of activity? Are there brain rhythms involved? I think I've heard about gamma waves.
Yes, absolutely.
Huh.
That brings us to gamma wave synchronization. These are very fast electrical oscillations in the brain, typically in the range of 30 to 100 hertz.
Faster than other brain waves like alpha or theta.
Much faster. And what's intriguing is that synchronized gamma activity often correlates strongly with moments of conscious awareness, particularly during focused attention or when binding different features of an object together.
Binding, like the binding problem we talked about.
Exactly. Remember how the brain processes color, shape, motion separately? One hypothesis is that gamma synchronization acts like a timing signal, linking the neurons processing these different features together, effectively binding them into a single, coherent, conscious percept in time.
So the rhythm helps tie it all together.
It might be the brain's way of saying, these bits of information belong to the same conscious moment. It helps create that unified experience.
These NCCs are fascinating, but how do researchers actually study them? Especially when consciousness seems to change or even disappear under certain conditions.
That's where studying extreme conditions becomes incredibly revealing. It gives us unique windows into how consciousness operates, or fails to. Consider split brain studies.
Right, where the connection between the two brain hemispheres is cut, usually for epilepsy.
Exactly. The corpus callosum, that thick bundle of nerve fibers connecting the left and right hemispheres, is severed. This procedure has yielded some truly mind-bending insights.
What happens? Does the person feel like they have two minds?
It's complex. What's clear is that information presented to one hemisphere is often not accessible to the other, especially for verbal report.
So if you show something to the left eye, that goes to the right brain hemisphere.
Correct. And the right hemisphere typically doesn't control speech. So if you ask the patient what they saw, they might say, nothing.
Even though the right brain saw it.
Yes. But, and here's the fascinating part, their left hand, which is controlled by the right hemisphere, might be able to draw the object or pick it out from a set of items.
Wow. So one part of the brain knows, but the part that talks doesn't.
Precisely. It demonstrates a clear dissociation of awareness. And it leads to some bizarre phenomena, like the classic example of the left hand acting seemingly with its own intention, maybe trying to unbutton a shirt, while the right hand, controlled by the verbal left hemisphere, is trying to button it up.
Alien hand syndrome.
Related, yes. The profound implication is that consciousness might be less unified than our introspection suggests. Perhaps it's more fragmented, more distributed. Cutting the main communication cable reveals potentially independent streams of awareness, or at least processing, within one skull.
Makes you question your own sense of unity.
It really does. Another powerful tool is studying anesthesia and consciousness switches. Anesthetics are remarkable, aren't they? They temporarily and reversibly eliminate subjective experience.
Turn off the lights, basically.
Exactly. By studying how different anesthetics work, they affect various neurotransmitter systems and brain networks. Researchers can pinpoint neural processes that seem necessary for consciousness. Disrupting integrated information flow seems to be a common theme.
Do people just fade out slowly?
Interestingly, no. Research suggests it's often more like a switch than a dimmer. Consciousness seems to transition quite sharply, both when being lost and regained.
A critical threshold.
It seems so. There appears to be a critical threshold of complex, integrated neural activity. Fall below it, consciousness winks out. Cross back over it, it comes back online. This suggests a nonlinear process where small changes in brain state can trigger a massive shift in conscious experience.
So, okay, we've explored the brain's architecture, its rhythms, how consciousness can be split or switched off. We have lots of correlates, but we keep bumping up against that hard problem. How does any of this physical stuff generate the subjective spark, the actual feeling?
Right, the NCCs tell us what brain activity goes along with consciousness, but not why it feels like something.
This is where the big theories come in, right? The attempts to actually bridge that explanatory gap.
Exactly. Researchers have developed several bold, sometimes quite controversial theories trying to explain how consciousness actually arises from all this neural machinery. They try to tackle the hard problem head-on.
Okay, let's dive into them. What are the leading contenders?
Well, if we connect this back to the bigger picture, each theory tries to bridge that gap from physical processes to subjective experience, but they come at it from very different angles. They offer different answers to the why question.
Where should we start?
Let's start with a really influential one. Integrated information theory, IAT, primarily developed by Giulio Tononi.
Integrated information. Okay, what's the core idea?
The core idea is pretty radical. IIT proposes that consciousness is integrated information. Any system, biological or not, that can integrate a large amount of information in a complex, unified way possesses consciousness.
So it's about the system's structure and how it processes information.
Precisely. It's about the causal structure of the system, how its parts affect each other. IIT tries to quantify this. It defines a mathematical measure called phi, represented by the Greek letter phi.
What does that measure?
Phi, roughly speaking, measures the amount of information generated by a system as a whole, above and beyond the information generated by its parts independently. It quantifies the degree of integration and differentiation in the system.
So higher phi means?
Higher phi means more consciousness. A system with high phi has a structure that is both highly differentiated, it has many possible states, and highly integrated. Its parts are strongly interconnected and influence each other.
And the implication is anything with a high enough phi value is conscious.
That's the really mind-bending implication, yes. IIT predicts that consciousness isn't exclusive to brains. Theoretically, any system with the right kind of complex, integrated structure could be conscious, regardless of what it's made of.
So maybe a sufficiently complex computer network? Or, I heard even simpler things.
Well, the theory, taken to its logical conclusion, suggests even very simple systems might have a tiny amount of phi, a minuscule degree of consciousness, perhaps even something like a photodiode connected in a certain way. This is obviously deeply counterintuitive.
Yeah, the idea of a conscious photodiode is hard to grasp.
What are the main criticisms of IIT? The counterintuitive predictions are one major hurdle for acceptance. Another huge challenge is actually calculating phi for any complex system, like a human brain. The mathematics involved are incredibly complex and currently computationally intractable for large systems.
So it's hard to test empirically.
Extremely hard.
Well,
While it provides a mathematically precise framework, translating that into feasible experiments, especially for verifying consciousness in non-biological systems, is a massive challenge. But it's a very active area of research.
okay, IIT consciousness is integrated information. What's next?
Let's look at global workspace theory, GWT, associated with Bernard Bars and further developed neuroscientifically by Stanislas Dehaene and others. This one is perhaps more intuitive for many.
We touched on this with the NCC's the spotlight analogy.
Exactly. The core idea is that consciousness emerges when information processed locally in specialized unconscious brain modules gains access to a global workspace.
The main stage.
The main stage. Once information is in this workspace, it gets broadcast widely across the brain, making it available for various high-level cognitive processes like verbal report, long-term memory storage, planning, and voluntary control. Consciousness, in this view, is this state of global availability.
So it's less about what the information is, like in IIT, and more about where it goes and what it can do.
That's a good way to put it. It focuses on the functional role of consciousness, making information flexible and accessible for complex tasks.
And you mentioned this has stronger empirical support.
It does have strong support from neuroimaging. Studies consistently show that when a stimulus crosses the threshold into conscious awareness, there's a characteristic pattern of brain activity, a widespread activation, often involving those prefrontal and parietal regions, sometimes called ignition. It looks like information going global.
So GWT seems more grounded in observable brain activity.
It aligns well with much of the NCC research, yes, though it arguably focuses more on access consciousness, information available for report and control, and might not fully address the phenomenal consciousness, the subjective feeling aspect of the hard problem to everyone's satisfaction.
Right, the what it's like part might still be elusive. Okay, what else? I remember hearing about a theory involving quantum mechanics.
Ah, yes. That would be the orchestrated objective reduction, or R theory, proposed by the physicists Sir Roger Penrose and the anesthesiologist Stuart Hameroff.
Quantum mechanics and consciousness, that sounds ambitious.
It's certainly ambitious and highly controversial. The core idea is that consciousness doesn't arise from classical neural computation, but from quantum processes occurring within microtubules.
Microtubule, those are structures inside neurons, right? Like scaffolding.
Exactly. Tiny protein cylinders that form the neuron's cytoskeleton. Penrose and Hameroff proposed that quantum coherence, a delicate quantum state where particles can exist in multiple states at once, can be maintained within these microtubules, allowing for a form of quantum computation.
Quantum computing inside brain cells.
That's the idea.
Yeah.
And they propose that consciousness arises from the objective reduction, a term from Penrose's physics, which is essentially the collapse of these quantum states into definite classical states. Each collapse, they suggest, corresponds to a moment of conscious experience. This collapse is orchestrated by the microtubule structure.
Okay. Wow. What's the major pushback against this? I seem to recall something about the brain being too messy.
You nail the central criticism. The brain is generally considered far too warm, wet, and noisy an environment to sustain the kind of delicate quantum coherence needed for ORGR, at least for the timescales relevant to conscious thought. Quantum coherence usually requires extremely cold and isolated conditions.
So most neuroscientists are skeptical.
Highly skeptical, yes. While there have been some intriguing findings in quantum biology showing quantum effects in other biological processes like photosynthesis, extending this to consciousness in microtubules is a huge leap that lacks strong evidence and faces significant biophysical hurdles. It remains very much a fringe theory within mainstream neuroscience.
Interesting, though. Okay, moving away from quantum strangeness, what's next?
Let's consider attention schema theory, AST, proposed by neuroscientist Michael Graziano. This one offers a rather different perspective.
Attention schema, what does that mean?
Graziano suggests that consciousness isn't some mysterious extra property, but rather it's the brain's internal model of its own process of attention.
Like how the brain builds a model of the body, a body schema to know where its limbs are.
Exactly the same principle. Just as the brain constructs a body schema to track and control the body, Graziano argues it also constructs an attention schema to track and control its own focus of attention.
So consciousness is the brain's representation of its own attention.
That's the core idea. What we experience as subjective awareness or consciousness is actually this internal model, a somewhat simplified, schematic representation of the state of our attention.
And qualia, the feeling of redness.
According to AST, qualia are like features within this model. The experience of seeing red isn't the raw redness itself, but the brain's internal signal representing the state of attending to the property we label red. These subjective qualities are, in a sense, useful cartoons or summaries the brain creates to represent and help control its attentional focus.
So it's a theory about function modeling attention that aims to explain subjective experience as part of that model.
Precisely. It tries to ground consciousness in a specific, computationally modelable brain function. An advantage is that it makes more concrete, testable predictions about brain activity related to attention and awareness, and potentially offers a path towards implementing something analogous in artificial systems.
Fascinating. Okay, one more major category, I think. Something about consciousness being everywhere.
Ah, yes. That brings us to panpsychism. This isn't a single scientific theory like the others, but rather a broad philosophical position, though one that's seen a resurgence in recent discussions about consciousness.
Panpsychism. Pan meaning all, psyche meaning mind. So mind is in everything.
Essentially, yes. The core idea is that consciousness, or at least some rudimentary form of proto-consciousness, is a fundamental and ubiquitous property of matter. It's not something special that emerges only when matter becomes complexly organized like in a brain. Instead, it's there at the base level of reality, perhaps inherent in particles like electrons or quarks.
Wow. So even a rock has some tiny bit of consciousness.
According to some versions of panpsychism, yes, though perhaps an incredibly simple form we can barely conceive of. The idea is that complex consciousness like ours arises from the combination of these fundamental microconscious entities.
Okay, but how do they combine? If every little bit has its own tiny consciousness, how do they merge into my single unified experience?
You've hit upon the absolute central challenge for panpsychism, the combination problem. How do these myriad bits of microconsciousness or proto-consciousness combine to form the rich, unified macro-consciousness that we experience? What's the binding mechanism for consciousness itself at this fundamental level?
It sounds like it just pushes the mystery down a level.
That's a common criticism. While panpsychism offers a potential way around the hard problem, by saying consciousness never arises, it's always there, it faces this incredibly difficult combination problem. Furthermore, it's extremely difficult to test scientifically. How would you detect the consciousness of an electron? So it remains a highly controversial philosophical stance, though one that some physicists and philosophers find appealing for its potential ontological simplicity.
So many different approaches. IIT, GW2, ORQUAR, AST, panpsychism, all trying to crack the same nut. But this brings us back to a fundamental issue. How do you even study this stuff objectively?
Exactly. This is the core methodological dilemma. How do you apply the objective methods of science to something that is, by its very definition, subjective and private? It's that first-person versus third-person divide rearing its head again.
Can science truly capture something experienced only from the inside?
That's the million-dollar question, isn't it? It forces researchers to be incredibly creative and develop indirect methods. We can't directly measure your experience of red, But we can measure what your brain is doing when you report seeing red, or when other evidence suggests you're experiencing it.
Which brings us back to the neural correlates, the NCCs.
Yes, identifying neural correlates is a cornerstone. Find brain activity patterns that reliably correlate with specific conscious experiences. See what lights up when someone becomes aware of a sound versus when they don't.
But correlation isn't causation, right, or explanation.
Precisely. Finding a correlate is crucial. It tells you where and when to look in the brain. But it doesn't by itself explain how that neural activity becomes the subjective experience. It's like knowing the engine is running when the car moves, but not understanding internal combustion.
So we need more objective measures, if possible.
Researchers are constantly seeking them. One promising approach is a Perturbational Complexity Index, PCI, developed by Marcello Massimini and colleagues.
PCI, how does that work?
Basically, they give the brain a little zap using transcranial magnetic stimulation, PMS, and then use EEG to measure how complex and widespread the brain's electrical response is.
So you ping the brain and see how it resonates.
Exactly. The idea is that a conscious brain, being highly integrated and differentiated, will respond with complex, far-reaching patterns of activity. An unconscious brain, like during deep sleep or anesthesia, or perhaps in some coma states, responds much more simply, locally. Higher PCI values seem to reliably indicate higher levels of consciousness.
And that's useful because you don't need the person to report anything.
Correct. It offers a potential objective biomarker of consciousness level, particularly valuable for non-communicative patients.
What other clever techniques do they use?
There are ingenious experimental paradigms like visual masking and binocular rivalry. In visual masking, you flash an image so briefly, followed immediately by another masking image, that the first image doesn't reach conscious awareness.
So the brain processes it, but you don't consciously see it.
Right. By comparing brain activity, when the stimulus is seen versus when it's masked, but still processed unconsciously, researchers can try to isolate the extraneural activity associated specifically with conscious awareness.
And binocular rivalry.
That's where you present different images to each eye, simultaneously say, a picture of a house to your left eye and a face to your right eye.
What do you see? A mix.
No, interestingly, your perception doesn't blend them. It spontaneously flips back and forth. You'll consciously see the house for a few seconds, then suddenly the face, then back to the house, even though the physical input to your eyes hasn't changed at all.
So the input is constant, but the conscious experience changes.
Exactly. This allows researchers to track what changes in the brain correlate precisely with the switch in conscious perception, helping to disentangle awareness from mere sensory processing.
Clever. But relying on people's reports still seems central.
It is, but it's also debated. This leads to the discussion around report versus no report paradigms. Many studies rely on subjects verbally reporting. Yes, I saw the stimulus. But some argue that requiring a report might contaminate the findings.
How so?
Maybe the neural activity you measure isn't just for the conscious experience, but also for the processes involved in accessing that experience and preparing a verbal report. That might be part of the easy problem of access consciousness, not the hard problem of phenomenal experience itself.
So you might be measuring the reporting, not the raw feeling.
That's the concern. This has led to no-report methods that try to infer consciousness from more subtle behavioral cues, like eye movements, or directly from brain signals, without asking for an explicit acknowledgement. It's an ongoing methodological debate trying to get closer to the raw subjectivity.
And underlying all of this is that deep philosophical issue. How do we know anyone else is conscious?
Ah, yes, the problem of other minds. It's a classic. How can you really know with absolute certainty that anyone else experiences the world subjectively like you do?
We just assume they do because they act like us and talk like us.
Exactly. We make an inference based on behavior and analogy to our own case. But it's an assumption, not direct proof of their inner experience. This isn't just an abstract puzzle. It has acute relevance.
Like with patients who can't communicate.
Patients in vegetative states, yes. Are they conscious but unable to respond? How can we know? Or consider animals with very different brains. Octopuses, crows. How do we assess their consciousness?
And AI.
Artificial intelligence, absolutely. If an AI acts incredibly intelligently, even claims to be conscious, how can we verify it? And think back to those split-brain patients, is there one consciousness or two inside their head? The problem of other minds forces us to confront the limits of our objective methods when dealing with subjective states.
So if consciousness is such a profound mystery even in ourselves, what about extending that question outward? To animals, to AI. That feels like venturing into even deeper water.
It certainly does, and the implications, both scientific and ethical, are enormous. Let's take animal consciousness first. This isn't just academic curiosity. Acknowledging consciousness in other species fundamentally shifts our moral landscape.
How we treat them, you mean?
Absolutely. A major landmark here was the Cambridge Declaration on Consciousness back in 2012. A prominent group of neuroscientists gathered and declared, based on the evidence available then, that non-human animals specifically, including all mammals, birds, and even some invertebrates like octopuses, possess the neurological substrates for consciousness and exhibit conscious behaviors.
So the scientific consensus is leaning towards animals being conscious.
The consensus has definitely shifted significantly in that direction, yes. It wasn't just a fringe opinion. These were leading researchers concluding the evidence was compelling.
What kind of evidence? Is it just brain similarity?
Brain similarity is part of it, but also the idea of evolutionary continuity. If consciousness provides survival advantages, better problem-solving, more flexible behavior, enhanced social bonding, it makes evolutionary sense that it wouldn't just suddenly appear out of nowhere in humans. It's likely to be present in other species facing similar challenges, perhaps in different forms or degrees.
So what behaviors suggest consciousness in animals?
There's a wealth of behavioral evidence. Think about self-recognition in mirrors seen in great apes, elephants, dolphins, even magpies. That suggests a form of self-awareness.
Complex emotions, like dogs seeming happy or sad.
Complex emotional responses, yes. Grief-like behavior in elephants or chimpanzees, apparent joy, fear, these seem to go beyond simple stimulus response. Then there's sophisticated problem-solving, tool use, and even manufacturing by some species, like crows, and evidence of planning for the future. These point towards flexible internal awareness, not just rigid instinct.
And does the neural evidence back this up?
Yes, the neural evidence is increasingly supportive. Many animals possess brain structures analogous to those linked with human consciousness. Even birds, whose brains are organized quite differently from mammals, have complex neural circuits that support sophisticated cognition and show activity patterns during wakefulness and sleep that resemble ours, suggesting convergent evolution of consciousness-supporting mechanisms.
Okay, so the case for animal consciousness seems strong. What about the other frontier? Artificial consciousness.
AI. This is where things get really speculative, but also urgent, given the pace of development. Let's be clear about current AI. Systems like ChatGPT, LaMDA, AlphaFold, they are incredibly powerful and can mimic human conversation or solve complex problems in ways that can seem intelligent, even insightful.
But are they feeling anything?
The overwhelming consensus among AI researchers and neuroscientists is no. Current AI systems are generally thought to lack subjective experience, qualia, genuine understanding, or sentience. They are sophisticated pattern-matching machines processing vast amounts of data to generate statistically probable outputs. They simulate intelligence, but don't possess inner awareness.
So right now, they're essentially very advanced philosophical zombies.
That's a good way to think about it. They can perform the functions remarkably well, but there's likely no lights on inside. But the crucial question is about future possibilities.
Could AI become conscious as it gets more complex?
That's the multi-trillion-dollar question. Some researchers believe that yes, as AI systems become vastly more complex, perhaps achieving brain-like architectures with high levels of integrated information, connecting back to IIT maybe, consciousness might emerge as an inherent property of that complexity.
Well, others think it needs biology, or something else entirely.
Exactly. Others argue consciousness is tied specifically to biological processes, maybe quantum effects, like Or suggests, however controversially, or specific neurochemical environments that silicon chips just don't replicate. Or perhaps it requires a different kind of computational principle altogether that we haven't discovered yet. It's a fundamental debate with no clear answer.
And how would we even know? The Turing test isn't enough.
Definitely not. The Turing test assesses intelligent behavior, the ability to fool a human into thinking it's interacting with another human. It says nothing about inner experience. We'd need something exceptional.
Beyond the Turing test, maybe objective measures like PCI adapted for AI, or entirely new tests specifically designed to probe for subjective awareness, not just clever mimicry. Developing such tests is a huge challenge.
And if we did create conscious AI, the ethical implications, they are staggering. If an AI becomes genuinely conscious, sentient, it raises profound questions about ethical implications. Does it deserve moral consideration? Does it have rights? How should we treat it? Could it suffer? How would we ensure alignment with human values if it develops its own subjective goals and experiences? These aren't just sci-fi scenarios anymore. Ethicists and AI safety researchers are grappling with these foundations now to prepare for potential futures.
It's mind-boggling. Okay, so despite all these theories, all the NCC hunting, the animal studies, the AI speculation, that central hard problem still looms large. Why? Why is consciousness so uniquely stubborn, so resistant to our usual scientific methods?
It really is uniquely resistant, isn't it? And there seem to be a collection of deep conceptual and methodological hurdles that keep tripping us up. One of the biggest is what philosopher Joseph Levine famously called the explanatory gap.
We mentioned this earlier, the gap between the physical brain and the subjective feeling.
Exactly. It's the persistent difficulty, maybe even impossibility, of explaining how purely physical processes, neurons firing, chemicals diffusing, could possibly give rise to subjective experience.
Yeah.
We can describe the physical chain of events in exquisite detail, but the connection to why that chain should be accompanied by the feeling of redness or the taste of chocolate seems missing. There's a gap in the explanation.
It feels like different kinds of stuff, physical stuff and experience stuff, and no obvious bridge.
That's the intuition. And this gap is powerfully illustrated by another famous thought experiment, the knowledge argument, often involving Mary the color scientist.
Ah, yes, Mary in the black and white room.
That's the one. Imagine Mary is a brilliant neuroscientist who knows absolutely everything there is to know physically about color and color vision. She knows all the physics of light waves, all the neurobiology of the retina and visual cortex, every functional detail.
But she's lived her whole life in a black and white environment, never seen actual color.
Right. Then one day, she's released from the room and sees a ripe red tomato for the first time. The question is, does Mary learn something new?
Intuitively, yes. She learns what it's like to see red.
Most people agree. If she does learn something new, the quale of red, then it implies that her complete physical knowledge was incomplete. There's something about conscious experience itself that cannot be fully captured by purely physical descriptions, no matter how detailed. This argument suggests physicalism, the view that everything is physical, might not be able to account for consciousness.
Another deep puzzle. What else makes it so tough?
Well, we also keep running into the combination problem. We discussed it in the context of panpsychism, but it's actually a broader challenge.
How do the little bits make the big whole?
Essentially, yes. Even if you don't think individual electrons are conscious, how do the activities of billions of individual neurons, each doing its own relatively simple thing, combine to create your single, unified, coherent stream of consciousness? How does distributed processing yield integrated experience? It's a binding problem, but maybe at a deeper structural level. Any theory of consciousness needs to explain this unity.
And our scientific tools themselves might be limited.
That's definitely a factor, the methodological limitations. Science, by its very nature, thrives on objectivity, third-person observation, measurement, and reproducibility. Consciousness is inherently subjective, first-person, qualitative, and private.
So it resists the standard toolkit.
It fundamentally challenges it. How do you objectively measure a feeling? How do you publicly verify a private experience? This doesn't necessarily mean consciousness is forever beyond science, but it might require radical new methods. Perhaps ones that can somehow bridge the first-person, third-person divide, or maybe even new forms of scientific explanation altogether.
It makes you wonder. Maybe we're just asking the wrong questions.
That's one possibility, often framed as a potential category mistake. Maybe we're trying to explain consciousness using concepts and frameworks that simply don't apply, like trying to measure the weight of happiness. Perhaps our very language and conceptual tools are inadequate for the task.
Or maybe we are inadequate, our brains.
That's another sobering thought, the idea of cognitive or structural limitations. Perhaps our brains, as products of evolution geared towards survival and reproduction, simply lack the cognitive architecture needed to fully comprehend their own consciousness. Just like a dog might never grasp calculus, maybe we're constitutionally incapable of solving the hard problem.
An evolutionary mismatch brains built for chasing mammoths, not solving deep metaphysics.
Something like that. Our cognitive faculties might be powerful, but ultimately limited in scope. However, countering this pessimism is the optimistic view, which points out that throughout history, many phenomena once considered deep, impenetrable mysteries, the nature of life, vitalism, heredity, the movement of planets, the causes of disease, eventually yielded to scientific inquiry through new theories, new tools, and paradigm shifts.
So maybe consciousness seems impossible now, but give science time.
That's the hope. Proponents of this view believe that continued progress in neuroscience, physics, AI, and philosophy, coupled with technological breakthrough we can't yet imagine, will eventually provide the concepts and data needed to crack the enigma. The mystery persists now, but perhaps not forever.
Okay, so this isn't just some abstract philosophical game or a niche scientific puzzle. It feels like understanding consciousness or failing to has really significant, tangible consequences.
Oh, absolutely. The stakes are incredibly high, far beyond academia. Think about the medical and clinical implications.
We touched on this with disorders of consciousness.
Exactly. A better understanding could revolutionize how we diagnose and treat patients in vegetative states, minimally conscious states, locked-in syndrome, or coma. Accurately assessing residual consciousness is crucial for prognosis, treatment decisions, and respecting patient dignity.
And anesthesia.
Improving anesthesia safety and effectiveness. If we truly understood the mechanisms by which consciousness is reversibly switched off, we could design better drugs with fewer side effects and monitor patients more precisely during surgery.
What about mental health?
Huge potential impact on mental health. Many conditions like depression, schizophrenia, anxiety disorders, PTSD involve profound alterations in subjective experience, self-awareness, or emotional regulation. Understanding the neural basis of normal consciousness could unlock new ways to understand and treat these debilitating disorders.
And those really difficult end-of-life questions.
Absolutely. Questions of consciousness are right at the heart of end-of-life decisions, defining brain death, assessing quality of life, respecting advanced directives, determining futility of care. These incredibly sensitive issues often hinge on our understanding, or lack thereof, of consciousness and when it is definitively lost.
So the medical stakes are huge. What about beyond medicine? Technology?
The implications spread widely into artificial intelligence and technology. We already discussed the ethics of potential future conscious AI.
Machine rights, safety, control.
Exactly. Machine rights and safety become paramount if sentient AI emerges. How do we ensure their well-being? How do we guarantee they align with human values? Conversely, understanding human consciousness could help us design better human-AI interaction. Imagine AI that could genuinely grasp human subjective states, leading to more empathetic and effective collaboration in fields like education, healthcare, or companionship.
And then there are the really big, deep questions.
The philosophical and existential implications, yes. These might be the most profound. If consciousness turns out to be fundamental, maybe as panpsychism suggests, it could revolutionize our understanding of the nature of reality itself, potentially requiring revisions to physics.
And our sense of self.
Our understanding of personal identity, what makes you continuously you over time. Is the unified self an illusion constructed by the brain, as some neuroscientists and philosophers argue? Or is there a deeper core? How does memory relate to identity? Consciousness is central to these questions.
Free will, too.
The age-old debate about free will. Is our conscious intention the true cause of our actions? Or is it a post hoc rationalization of unconscious processes? Clarifying the role and timing of conscious awareness in decision-making is key to this debate.
And ultimately, meaning?
For many, consciousness is inextricably linked to finding meaning and purpose in life. It's the medium through which we experience joy, love, beauty, suffering, and connection. Understanding consciousness is, in a way, understanding the very fabric of our lived existence and what makes life valuable. The stakes really couldn't be higher.
So after this whole journey, what does this all mean for us? We've gone through the sheer complexity, the enduring mystery, from everyday qualia to quantum physics and AI futures. Consciousness is something you carry with you right now, this very moment. The very fact that you, listening, can understand these words, reflect on them. That is the mystery in action. It's what makes you you.
And what's really fascinating, I think, is that even with all the incredible progress in science and philosophy, that hard problem, the why of experience, it just persists. It keeps reminding us there are truly fundamental questions about existence that we haven't answered yet.
Yeah, it's humbling.
It is. And the theories we've explored, IIT, GWT, OR, attention schema, panpsychism, they each offer valuable pieces, different angles, different insights. None provide the complete picture, but that's not necessarily a failure.
More like a sign of how deep the problem is.
Exactly. It's a testament to the profound nature of consciousness. Whether it eventually yields completely to scientific explanation or maybe requires entirely new ways of thinking, or perhaps even remains partially mysterious. The quest itself is driving some of our most innovative research and our deepest reflections on what it means to be human.
It pushes us forward.
Absolutely. It forces us to question our assumptions about mind, matter, reality.
And maybe, in a world that sometimes feels like everything can be explained or reduced, the enduring wonder of consciousness is actually one of the most remarkable things about being alive.
That's a beautiful way to put it.
Every single moment of your awareness, your subjective experience, it's like this small personal miracle happening constantly that science, for now, can't fully explain.
It really is.
So, as you go about your day after listening to this, aware of your surroundings, feeling emotions, thinking thoughts, making choices, here's a final provocative thought to consider. What if the deepest answers about consciousness aren't ultimately found just by dissecting the brain into smaller and smaller physical components?
Where are you going with this?
What if a crucial part of the puzzle lies in turning our attention inward, towards the raw, subjective, first-person experience itself? What if the key isn't just reducing consciousness, but also appreciating its seemingly irreducible nature? Something to ponder.
Definitely something to ponder.
Thank you for joining us on this deep dive into the enigma of awareness. We really hope this exploration has given you a shortcut to being well-informed on this incredibly complex topic, and maybe left you with even more fascinating questions to chew on.